Take it away.
Hi, we're the secondScreen team. I'm Isaac.
I'm Nika.
I'm Aaron.
I'm Chance.
All right, so what we're creating is a second screen experience, and this is something that already exists. It's basically like you have a main screen that's showing some kind of content like a movie, and then you have a secondary app that is meant to give you more information and enhance the viewing experience of whatever's on the main screen. So this could be like an app that tells you what actors are currently on screen, or it might tell you like behind the scenes like information. Yeah.
So for our specific secondScreen experience, our client is Rose Thomas, who works for the North American retail expansion team at Amazon. And so her vision is a secondScreen experience that works specifically for Fire TV users. And the application is basically that you have someone who's watching something on their Fire TV. They can be streaming, Netflix or Hulu or whatever. And they also have their phone that's using this app. Basically, they see anything that they think is cool on screen that they want to buy. They're basically able to screenshot the screen, and then they can basically get results of all the things that are similar to that they can purchase right now. So if they saw like a desk or a dress on the screen, they'd be able to like use our app to purchase it.
So we had 4 main customer requirements. The first customer requirement was a mobile app that could communicate both with the Fire TV and our backend services, take screenshots from the Fire TV and throw those up to the backend services for a visual search. We also needed to produce product links from the Amazon web store based off of those visual search results. And the mobile app also needed to be easy to use because it's supposed to be used by pretty much anyone.
So this is kind of the high-level life cycle of our app and how it's going to work. So after you launch both apps, you'll be prompted to log in on to your Amazon account on the phone. And then once you're logged in, it'll scan the local area network for devices running our app. Once it sees a device, you can pair with it. So then once you're paired, it'll just wait until you send the screenshot command. Once you send the screenshot command, it'll take a screenshot on the TV and transfer that image from the TV back to the phone, at which point it'll go, the image on the phone will be uploaded to the cloud, where an initial image recognition search will be run. That will just get some basic information about the item, such as what it is, just like a dress, a desk. And then that tag will be used to do a secondary visual search to compare it to products on the Amazon catalog, so it can try to find a matching item. So it's not just a dress, but it's that specific dress that character is wearing. Once they have that more precise image, it'll be sent back to the user.
So next, we're just going to talk about some of our design choices that drove us to use a specific implementation we have for our minimum viable product. It's basically split into 3 main categories. So you have the Fire TV app, the decisions there, the back end, and as well as the cloud services. And then you also have the front end app development choices we had to make there. So we'll go into each one of those individually here.
So for the Fire TV app, there isn't a ton that needs to go on. It's mostly running as like a background service, just waiting to receive a command. But there were a couple of different options about how we could implement it. So the first was to use the Android debug bridge, which is a built-in Android function, which would run on the Fire TV because it runs Android. And it has some really useful functionality and makes it pretty easy to just request a screenshot and download it on the local device. Second option was to use an Android peer-to-peer connection, which is like a bit of a lower level sort of local area networking protocol that's a little harder to use in Android debug, but in theory easier than Fireflame. And the last option is the Fireflame API, which is a default Amazon pairing API that Amazon makes to make pairing between your phone and TVs really easy. So we ended up going with Fireflame because it works best with Fire TVs. So Android debug bridge doesn't run locally on mobile devices, so we ended up not being able to use that. And then the peer-to-peer connections are actually how the TV talks with the remote. So we weren't able to use that because it only allows one connection at a time. So the main focus of our TV app was it needs to run in the background and always be listening. To do this, we use the Firefly service. It's easy to use for users. They just see the name of the device in English. There's no weird stuff going on. They just click it and it should pair. In theory, Firefly can be easy to develop. Having all these background listeners and threads can sometimes be an issue, but it should be somewhat easy to develop. It needs to be able to take a screenshot on command. There can be some issues where you're switching apps and it tries to screenshot an app that's not itself, but that's the goal we try to do with that. And then it needs to be able to transfer an image file.
So for mobile app development, we had three primary choices. The first was cross-platform development. There's multiple frameworks out there. Our representative here is React Native. Next option would be to program using Android Studio, which is in Java. And then the last one was Swift. Ideally, we would be able to develop cross-platform, deploy both Android and Apple products, but it turned out not to be as easy as we would have liked. So we ended up going with Android development because we all know Java, and it's pretty easy to use existing Fling services to communicate with the Fire TV. So the main components of our mobile app was that it needed to communicate with the Fire TV, tell it to take a screenshot, send it back, and then send that screenshot back up to the cloud to communicate with our cloud services, to then get back from that cloud services some sort of Amazon web store list of links that the user could then browse through and click on.
Right, so for the back end of our app, we had to make a few choices. So one of the things we needed to do was communicate between the phone app and the Amazon cloud services. And really the only option there was to use the Amplify app framework that Amazon makes. And that's kind of just a set of libraries and other, like a command line interface that make it pretty easy to communicate with AWS services.
So the next decision we had to make was for cloud communications, and this is specifically how do the services in the cloud communicate with one another. And there's basically two main ways that we saw to do that. A server option, which is using EC2, which is basically a virtual machine that's hosted by Amazon in the cloud. And that would basically be like a central hub that all the services would talk to, that would be live the entire time. Although we ended up going with the serverless option, which is Lambda. And the main reason for that is that there's a good amount of overhead in terms of pricing and always just making sure that it's live and there's no issues with that with EC2. So like I said, Lambda is a serverless thing. It works on triggers, which I'll talk about more on the next slide. But it's just a lot easier to use. The documentation is a lot more clear for our specific implementation. And it's also cheaper. And then the final cloud design choice that we had to make was storage. So how are we going to store the images that got uploaded to the cloud? And there's two primary things you could use. One is DynamoDB, which is a relational database, which can be nice. It has a lot of like special functionality for like doing queries and stuff like that. But the major downfall of it is that you can only upload file sizes of 64 kilobytes, which when you're uploading images is going to be way too small almost all the time. So we went to S3, which is a lot more simple. It has a lot less like power in terms of what you can do, but that's fine for us because we really only needed to like upload and download. And it also allows file sizes that are way beyond the scope of what we would need for images.
Great, so with the Amplify framework, we were able to use the command line interface to pretty easily add some cloud services to our app. So the phone app can upload images to the S3 bucket, and it can also download. And then along with that, we needed user authentication. So we used Amazon Cognito, which assigns, like, when you open the app, you log in, and you have a username and password. And basically, we need to assign permissions to all the users so they're actually able to upload to the S3 bucket, because without permissions, they would get access denied.
And so the last part of our cloud services that we implemented for our minimum viable product is the Lambda function, which basically what it does is it allows for the image that's in the cloud to be accessed by AWS recognition, which will then return a bunch of labels that correspond to like what's in the image and how likely it is that this specific label is in the image. We did it through basically setting up the Lambda function took three things. The first is that it took an S3 event, which is basically you can just go into your management console on Amazon and you can set up an event on a bucket, which will basically say anytime anything gets added to this bucket, I'm going to trigger this event. The event in turn triggers the Lambda function, and then the Lambda function has the code that will basically make the request to recognition, at which point recognition will do the detecting of the labels and it will return this response to Lambda, at which point we take the response and we upload that to another S3 bucket as a text file. Right?
So looking ahead to winter quarter 2020, we have 4 major milestones left to get through. The first of that is to solidify our user authentication. And then in February, we want to combine our mobile apps. Right now, we have 2 separate mobile apps, one communicating solely with the Fire TV, the other one communicating solely with the backend services. So we need to reconcile those, combine them into one final app. The third milestone we need to accomplish in February is to actually get web store results from Amazon. Currently, we're just detecting labels on the images. We're not actually searching the web store for results yet. And then lastly, we want to get a more sophisticated visual search using some other framework or API that'll directly try to image match based off of what's in the web store. And that is it for now. Any questions?
Nina has a question.
If not, we can
I have a question.
demo. Okay.
If nobody else has a question, I'm going to ask questions. Your questions are probably easier than mine. So you're using the phone to trigger an image capture, right? And then the image goes to the phone and then goes up into the cloud.
Yeah. So yeah, yes.
Um,
And then once it's in the cloud, we just let the cloud services sort of take over and do everything. And then eventually they're going to get like this results list of like purchasable items, and that's going to get like downloaded back onto the app.
And so the assumption here is that the TV can't do the capture and upload it directly to the cloud.
It is possible, but it's not as easy. There's like authentication considerations. Like you only want users to be able to upload and like read and write to their specific images, just for like security purposes. And if you do it directly from Fire TV app, like assigning credentials is a little weird if they're not like using the credentials that are associated with the phone app. So
There's like also in theory we would want to be able to take multiple screenshots and then the user could like scrub through them to find like the most clear picture. So that way they could do multiple photos and then the user would be able to select before it gets uploaded.
So you could do things like maybe box the images or
Yeah.
So recognition, right now all we have it returning in the response is just labels, but it will also give you bounding boxes for the labels it finds. So one of our next major steps there would be to actually draw bounding boxes on the images and then return that to the user so that they can basically, press on a bounding box and then it'll just do just that image for the resulting services.
Well, that sounds cool.
Yours.
So is the phone capturing like connecting to the screen as a TV and capturing what's on the screen, or are you actually really going to just take pictures of the screen as if you were just?
No, it sends like a command over Wi-Fi and then it takes a screenshot on the TV and transfers the image file.
Okay.
Is there a plan for like it isn't late
So we thought about that. The issue is, unless you have like root access to the Fire TV stick, there's no way to like cache previous frames. It's like the Fire TV stick is like pretty low resources, so you can't just like constantly be recording and hope that they like request a screenshot. So in theory, Maybe if like Amazon actually implemented it and you know they have root access to like their OS, it could be possible, but it's not really doable for us.
The screenshots that you guys store, are you like clearing those out after some amount of time from the S3 buckets? Because I know storage on there costs money.
Yeah, for right now, no. It does cost money, but again, these like the S3 solution is meant for like you know, businesses that can. You can have a lot in there before it really costs you money. So even with the free tier account, we could probably upload tens of thousands of images before we get charged anything. And even at that, it's like, I think it's like 1/100 of a cent per like upload. So realistically, for what we're going to be doing with sort of just a proof of concept stuff, it's pretty negligible.
So are you going to be doing the sort of machine learning, whatever stuff in order to actually recognize what those things are on the screen, or are you just laying the groundwork for that machine learning?
So yeah, the machine learning is pretty much all taken care of by the APIs themselves. We could try to do it ourselves, but those APIs are pretty solid. They get hit with like terabytes of training data every day, so they're like way more refined than anything that we could probably come up with. So.
All right, on to the demos.
So we have